The following video will demonstrate how to set a work offset using the Renishaw Inspection Plus with inside and outside probing cycle in either the X or Y axis, along with demonstrating the rectangle inside and outside probing routines if you wish to set both the X and Y axis at once. This will be a multi-video training tutorial series covering all things probing. We'll go through both the basic and advanced features of CIMCO probing in Mastercam and the probe operation of your machine. So make sure to follow along, like, and subscribe as we dive in. To begin, we can open Mastercam and select our machine. We will start by sketching a simple 4" by 4" rectangle in our graphics window, anchor it to center, and place on the origin. We can then apply this and now create a 3" by 3" rectangle, also placing it on the origin. Remember, if your crosshairs are not turned on, you can simply press your F9 key or click on View Show Axis button. Because the center of my part is located at the origin, the width or rectangle datum cycles are perfect for setting a work offset as they will probe both sides of the part and naturally find the center line. Let's continue on by adding some angled chamfers to the inside pocket for later use. You can do this by clicking the Chamfer Entities option on the Wireframe tab and verify that our method is set to 1 distance and set that distance to 1/2 inch. You can now click on the 2 intersecting lines that the chamfer will be located. Let's do this in the upper and lower left side of the part. You can then green check out of this function. Although a solid model or defining a stock setup is not required to utilize CIMCO probing, we are able to select certain geometry off of them. So let's create one in order to show how to do this, along with get a better visual of the part. I will first click on the Solids Extrude icon and chain the 4" by 4" square. We can then green check out of the chaining dialog and verify the direction that we are extruding. In our example, we want to go in a Z- direction, so can flip the arrow direction as needed and set our distance to 1 inch. This will then create a 4" by 4" by 1 inch block that will represent our raw stock. We can repeat this step by clicking the Apply button and then chain our 3" by 3" square. Again, green check out of the chaining dialog box, but this time clicking on the Cut Body option and setting our distance to 1/2 inch. Lastly, let's define our stock setup by clicking the Stock Setup menu located underneath the Machine Group Properties. I will use this option of bounding box and will set the 0 to top center of my part and click the options of All Shown. I now want to set my current plane's work offset number that I will be using on the machine. To do this, I will click on the Planes Manager and change my plane to Manual. In my example, I am going to be using an extended work offset of G154P10. Make sure to save your file so we can reference it later if needed. Now that we have all of our necessary geometry to probe both a web and pocket feature, let's click on the CIMCO Cycle Probing icon located on our CIMCO tab and go to the Workpiece Datum category. We are going to start off with the With Outside option. Since there are no tools currently defined in our part file, we can simply right-click in the Tool section and go to the Tool Manager. From here, we'll find our probe in the library and can double-click on it. This will then move it to the top, allowing us to use it in our part file. If you do not already have a probe defined and saved in your library, please watch our tutorial on how to define a probe. We will continue by giving our probe path a comment if you wish, followed by clicking on the Cycle tab and then right-clicking in the Geometry section. First, we'll turn on the setting of Automatic Toolplane Selection and save it as a default, as this will utilize our current selected toolplane to create the probe path. At any time, you are able to set specific default values per each probing cycle to expedite the process. Now that we have set that as a default, right-click again in the Geometry section. You will see that currently we allow you to pick on points or lines. Points will ask you to pick 4 points, where lines will allow you to pick on 2 wireframe and/or solid edges. In our example, we will use the Line option and select on the left and right side lines or edges. Once we do so, CIMCO probing is associated to that geometry and we can start defining specifics to this probe path. Looking at our current settings, you will notice that the x-axis, y-axis, measuring axis, and width are all defined based on the selected geometry. We can then define the specific measuring height, safety distance, and clearance height, along with a few others for this particular path as needed. You can define the measuring height by simply typing in a number, using your right mouse button click menu and using such an option of Z coordinate of a point, or use our center mouse wheel to scroll up or down, as this will increase or decrease the value. I will set mine to a negative 250. We can do the same thing for safety distance, as this will be the standoff distance from the part that the probe will position. I will set this to a positive 250, followed by the clearance height, which is the height that the probe will rapid to, from, and in between cycles. I will set this to 1 inch. Now that we have the basic values input, you can see a visual of the probe path on our screen and can adjust any values to get a live updated feedback. I will set the over travel distance if you wish, as this will allow the probe to travel past the expected coordinate without alarming out, along with the work offset number that we are currently using and wish to update. Again, in this example, we are using G154P10. Within the cycle, you have the option to print data, which will deprint out a probing report based on your machine's I/O channel and parameters. We can shift the work offset by a certain value after it's measured and set by using the datum set point option. You will notice a suppress probe on/off and measurement result tick box. The suppress probe on/off will keep the probe turned on while it's probing between cycles and can be set per operation. Measurement result will allow you to copy the probe's results into specific variables on your CNC control, so that way they can be used and referenced later. This is important because the standard variables that Renishaw writes into are constantly being overwritten per probing cycle. The feature-to-feature option will be covered in its own tutorial. Once you check out of the cycle, you can simulate it within Backplot, Verify, or Machine Simulation and see how it looks. You will notice that because the cycle is just setting the x-axis only, it will probe the left and right side of the part. If we wanted to set our y-axis, we can either create a new cycle or add an additional cycle to the operation we just created. We can do this by clicking on the operations parameters, followed by clicking on the cycle tab, and then right-clicking in the geometry window to select the lines again. This time, let's click on the lines in the y-axis. Once we do so, you will now see a visual path for the y-axis, and will notice that because I had previous settings already set in my first probing path, that those settings carry down into subsequent paths, and can adjust anything as needed. If we check out, we can simulate this operation again, and now see how it goes in the X and Y axis. If we post out the G code for this cycle, we will see what the Inspection Plus macro routines look like. Now, let's take a look at the code and how it runs on the machine. Looking at the Renishaw Inspection Plus code for our Haas mill, you will notice that the program is nice and short and makes the code very easy to read. As we go through, you will find the probe on and off commands, the probe's protected safety moves in order to approach and retract from the part safely, along with the width measurement cycle in the x-axis. We then define the height at which we wish to measure, keeping in mind that we are currently compensating for the probe radius. Next will be our Q value, which defines our over travel distance, our R value, which defines our standoff distance, along with the S number, which will be the work offset number that we are updating on the machine. We will then see the actual and the deviation results, which are being copied to my user-defined variables, so I can display the results on the control or use the results later. We then repeat the same process for the y-axis before ending our program. All of this information can be referenced by using the Renishaw Inspection Plus manual. Another way that we could have programmed the same motion is to use a rectangle outside feature, which will combine two width cycles together and probe in both the X and the Y axis. However, this cycle will automatically position the probe points to the center of the selected geometry. If you had an intersecting feature such as a cutout and could not probe on center, or you would like to probe the X and the Y axis at different depths, you would want to use two width cycles, as you can then adjust these settings independent of each other. Let's continue now by clicking on the CIMCO cycle probing icon, workpiece datum, rectangular outside. The workflow will be identical to our previous cycle, and because I already had selected a probe, we can bypass this and enter an operational comment if we wish. Next, we will click on the Cycle tab, followed by right-clicking in the Geometry section. You will notice that now in this cycle, we have the option to select on our geometry from stock, lines, or chains. From stock, we'll use the rectangular stock setup settings that we have defined earlier. Select lines will allow the user to pick on wireframe and/or solid edges. Select chains will allow us to use the wireframe chaining dialog box. In this example, I'm going to select from stock. Again, you will notice that the x-axis, y-axis, width, and height fields were defined based on my selected geometry. Let's again define the measuring height to a -250, our safety distance to a +250, and the clearance height to 1 inch. Let's also enable our over travel distance and set this to 0.125. We should now see a visual path on our part and then can adjust any settings as needed before closing out. The last thing I will set is our current work offset number to update on the machine, which will be G154P10 for my example. Once we click OK and check out, you can simulate the path within Backplot, Verify, or Machine Sim and see how it looks. You'll notice that this time it will probe the both X and Y axis within one cycle versus 2. Let's post it out and see how the code looks and how it would run on the machine. Now that we have seen a few different ways on how to probe the outside of your part, let's switch gears and show a few examples in order to pick up off of a pocket feature on the inside of your part. We'll begin by clicking on the CIMCO cycle probing icon, workpiece datum, width inside. We will enter a operation comment, click on our cycle tab, and then right-click in the geometry section. Similar to the width outside cycle, the width inside will allow for the same geometry selection of points or lines. Again, points will ask you to pick on 4 points, where lines will allow you to pick on 2 wireframe and/or solid edges. In our example, we will use the lines option and select on both the left and right side lines or edges. Once we do so, CIMCO probing is associated to that geometry, and we can start defining specifics to this probe path. Next, we will define our measuring height, clearance height, along with setting our probe over travel distance and work offset number to be updated. I will use the same values as we have previously set. You will notice this time that safety distance is an optional parameter. This can be used if there's an obstruction that would prevent the probe from simply moving straight across at its measuring depth in order to probe the second point. If we enable it and set it to a 0.250, we will now see that the probe positions and retracts a 1/4 inch from the wall and returns to the clearance height at which it will reposition to the second location. We can do the same thing for the y-axis and select on the upper and lower edges, as this will add in a second probe cycle. Let's disable the safety distance on this one so we can see the difference of it being turned on and off in simulation. Lastly, let's review doing the same thing, this time using the rectangle inside feature, as it will combine 2 width cycles together and probe in both the X and Y axis. The cycle will automatically position the probe points to the center of the selected geometry, and so if you had an intersecting feature such as a cutout and could not probe on center, or you would like to probe the X and Y axis at different depths, you would want to use 2 width cycles, as you can then adjust each of these settings independently of each other. In order to create this cycle, click on the CIMCO cycle probing icon, workpiece datum, rectangle inside. We will enter an operation comment, click on the cycle tab, and then right-click in the geometry section. This time, you will have the option to select from either lines or chains. If we use the chains option, you can simply click on the 3" by 3" square wireframe geometry and green check out of the chaining dialog box. You can then set your measuring and clearance height. If there would be an obstruction that would prevent the probe from repositioning to the second location while at its measuring depth, we can enable the safety distance option so the probe will retract to the clearance height before repositioning. I will set our over travel distance and work offset number and then green check out of the operation and run through simulation. Make sure to save your file so we can reference it later if needed. We hope that you have found this video beneficial. For further information, questions, or to request a free 30-day trial of CIMCO probing, please contact CIMCO or your local reseller today, or visit our website of probing.com. Thanks for watching.